My name is Paula Cushing. I'm a curator here at the Denver Museum of Nature and Science, and I'm also one of the co-founders and co-organizers of our Skirts in Science group here at the museum, which is our Women in Science group. And it's my great pleasure today to introduce Space Odyssey volunteer Betty Jo Armstead. In her student days, Betty studied chemistry and math, and as a young woman, she was fortunate enough to get a job with the National Advisory Committee for Aeronautics, which was the predecessor of the National Aeronautics and Space Administration, or NASA, where she eventually became a pioneer computer programmer, a female computer programmer for NASA. So today, Betty's going to give an overview of her career, and then we're going to open the floor to Q&A from the audience. And I don't want to take up a lot of time, but I do want to tell you one story. When I went to talk to Betty in Space Odyssey about the possibility of giving this talk, we had this fascinating conversation, and she said to me, she said, one of the most interesting things I did was I worked on this problem to figure out how to send a trajectory from the Earth to the Moon. It was an interesting problem because it was a three-body problem. And when she said that, I realized by three-body problems, she meant Earth, Sun, and Moon. And I don't know about you, but in my day-to-day life, it's not very often that I have to take into account planetary bodies when solving problems. So it's going to be a great talk, and I hope you have lots of questions for Betty. So without further ado, please welcome Betty. There's a railing. Got it?
I am going to read my talk because I don't memorize too well. And that may be because I'm 83 years old. Thank you, Paula, for the great introduction. And I'd like to talk to you about my years at NASA. At the time, I didn't realize there was anything exceptional about my story. I grew up on a farm in northeastern Missouri, and I really enjoyed my experience as a student. I had an outstanding math teacher in high school that really challenged me, and I loved every minute of it. Once I graduated, I only applied to one college because I could stay with an aunt and uncle in Illinois. I graduated from Eastern Illinois Teachers College in 1953 with a major in chemistry and a minor in mathematics. I was the only woman in that program at that time. Going into college, I actually preferred mathematics, but I didn't see any jobs in mathematics other than teaching, which I did not want to do. I actually had an aunt who came to my graduation with a contract in hand to teach, and I told her, go suck a lemon. I applied to Iowa State in Ames Graduate School and worked half-time as a teaching assistant. Because I was the only teaching assistant from the Midwest and much more understandable than the local students, many of the students sought me out. My tutoring classes ended up with about 20 students each, rather than the usual 2 or 3. The excessive tutoring load was taking too much of my time. Also, I was not happy with the chemistry professor who seemed to be teaching from the 18th century. That was such a contrast from the terrific professors I had at Eastern Illinois, and I dropped out of the program. Now, what do? I picked up the General Federal Government Applications Form and applied for a job. Because of my years of studying math, I was offered a position at NACA, National Advisory Committee for Aeronautics, located in Cleveland, Ohio. NACA had a number of jet engine test cells, as well as 2 supersonic wind tunnels. These facilities were used in the design and testing of jet engines. The power required by the tunnels was so great that when they ran them, they had to notify the Tennessee Valley Authority, TVA, which you in the West may not know about, but we in the East do. That's the power they do the power for a huge part of the USA. If it ever went down, everyone in that part of the country would lose power. One time there was an emergency shutdown on one of the wind tunnels. I think it was a 10 by 10. And the turbines at TVA actually began to turn backwards. The two main issues being dealt with were trying to increase engine efficiency and solving the problem of birds and objects flying into the airplanes, into the engines. The local residents were very upset when they found out that some of the engine tests involved throwing dead chickens into a running engine. When I walked into the computer area where I was assigned an NACA, what I saw was a room full of women seated at Frieden or Monroe calculators. These were fancy adding machines that could add, subtract, multiply, divide, and take the square root. Next to each machine were two pieces of paper, an input page and an output page. The input page contained engine test data such as temperature, pressures, etc. The data was recorded during tests by taking pictures of something that looked like a thermometer to me, and the women read the data from negatives of these pictures. My job was to provide the instructions for processing the data. This meant working with test engineers to provide these instructions. Based on their instructions, I would create appropriate column headings on the input and output sheets. The end results would tell the engineers how well the engine worked. Because I was working with engineers, I soon found more interesting areas that could use my talents. The engineers were relatively lacking in math and computer skills, so anyone knowledgeable and willing to work was welcome, even females. NASA had acquired an IBM 650 computer, which I volunteered along with a few others to learn to program. And it also included my supervisor, Marge Jarrett, which I recently found out she died. The IBM 650 had 60 36-bit words of electronic memory and read its instructions from a rotating drum. Compare that to the capacity of today's computers. I transferred to the aeronautics division so I could write programs for the IBM 650 supporting the engineers studying engine design. Soon after that, I went to work for Aaron Boxenbaum, who was quite a character. He's an engineer in the controls division, well known for thinking outside the box, and someone I really enjoyed working with. He was interested in calculating possible trajectories to the moon. I did write a program for the IBM 650 calculating a trajectory to the moon. This was early work. This work was really too early since NACA had no intentions of going to the moon. Although it was interesting, we did not have a practical use for the program at that time, since NASA was primarily designing and building jet engines. One of the funny stories, and I'm going off the text now for a second, was one of the problems they had with the rotor was the blades breaking off. So we had an engineer that got this really brilliant idea. He would make replaceable blades, and they fit into a nice little socket real tight. The day he fired that rotor up, blades went flying all over the test site. So it didn't work. Although it was interesting, we did not have a practical use. I also wrote a program at this point of calculating the trajectory to the moon. Although it was interesting, we did not have a practical use for the program at that time, since NACA was primarily designing, building, and testing jet engines. NACA did not become involved in the space industry until it became NASA in 1958. One of the funny stories about that time in my career was Aaron Boxenbaum and I had written a technical note, or you might say report, proving that rotating the thrust of the nozzle of a rocket engine perpendicular to the path of the rocket would effectively stop the forward momentum. We sent the report to NACA headquarters, and they rejected the report, saying they didn't understand it. So we just gave up on it. It was far more mathematical than what they were accustomed to, so it got shelved. I believe Aaron was busy with something else and just let it drop, which is very much his style. Another project I really enjoyed was working on Monte Carlo programs. Monte Carlo programs for NASA Nuclear Research Division to determine the shield thickness for a nuclear engine. In this case, random numbers generated were utilized to map out the probable pathway and an approximation that served to determine the thickness of the shield design. I had to find experts outside of NASA, who didn't have any, that knew something about Monte Carlo methods of computing. I remember calling the University of Maryland, I think, and got a professor there that was very helpful. It was fun and challenging project, and I had to make calls all over the U.S. to find people who could guide my work with Monte Carlo programs. It was a real learning experience. However, NACA lost interest in nuclear engines for spaceflight at that time. I finally transferred back to the computer division as it became more prestigious. Instead of a room full of women working on calculators, the computers were electronic. At that time, our primary computer was an IBM 650. The users, who were NASA engineers and scientists, were allowed to place their card decks in the card reader and wait for the output to be printed. The demand for computing became such that we were running the IBM 650 24 hours a day. This meant, by the way, that machine had only 60 words of electronic memory. This meant we needed operators, especially for the second and third shift. The jobs were run on a first-come, first-run basis. It also meant we needed more computing power, so we decided to test an IBM 704 computer since our needs were expanding. This story is kind of funny. My supervisor, Marge Sherb, and I had gone to IBM site in Washington, D.C. to test some of the jobs on the 704. We had been up all night getting all our test jobs to run, and we looked at, believe me. By then, we were very tired and running around in our stocking feet. The 704 was sitting in a large picture window that looked out on Pennsylvania Avenue in Washington, D.C. We both looked like we hadn't slept for 2 days. That morning, a group of people had gathered and was looking in the window at us, but it wasn't because of how we looked. The date was October the 4th, 1957, and that was the morning that Sputnik went up. Men from the government, we actually didn't know who they were, came and took the computer from us in order to track the Sputnik, since it was one of only a few computers capable of the task. Needless to say, we got no more testing done that day. And in a very short time, NASA became NACA. At that time, there were only 3 centers: NASA Langley Field in Virginia, NASA Ames in California, and NASA Lewis in Cleveland. Houston didn't exist. Cleveland, where I worked, later became named Glenn after astronaut John Glenn. After all that, we did acquire this IBM 704, which required a raised floor and lots of air conditioning. Buildings at that time were not constructed to account for the noise, heat, and electricity demand of large computers. The new computer ran very hot and had to be kept behind glass with heavy-duty air conditioning. The NASA engineers and scientists who were users were not happy at first because they could no longer have direct access to the computer. They had to leave their card decks for the operators to feed into the computer and wait for the output to be delivered back to them. Initially, their jobs were read directly into the computer, and the output went to an attached printer or card reader, and it was first come, first served. Eventually, when the backlog got larger, we would copy their jobs to tape, which we hoped to complete overnight. We had enough backlog of jobs so that a user might have to wait several days to get the results back. They were not happy. Up until this time, we had a pretty simple system of scheduling jobs. Jobs requiring more than 30 minutes were run after hours, and jobs under 30 minutes were scheduled as first come, first served. Also, we had not limited or charged for the amount of printed paper. After seeing lots of engineers pick up a full box of paper, look at the last page, and throw the rest out, we decided we had to do something. The first thing we tried was charging for paper. Since this was a fictional government charge, it didn't work. Then it became clear we needed a more sophisticated method of scheduling jobs. We began to require users to estimate run times and the number of pages of output. Since jobs with run times longer than 30 minutes and/or 50 pages were run at night, many people purposely underestimated run times and number of pages of output to try to cut into the line of jobs. It soon became obvious that in the daytime these estimates had to be strictly enforced, and jobs exceeding their page and time estimates were simply terminated. Users quickly learned to be more precise with their estimates. Around 1964, we acquired an IBM 7094/7044, a direct couple system, which was a hybrid platform with a shared memory connection between the two computers. It allowed newer human interfaces at the time. That was a high-speed card reader and high-speed impact printer. I think the printer printed about 1,000 words a minute or so. It was very fast. To be connected to IBM's primary scientific computer. Besides the printer and card reader access, this union also had another 32K, by that I mean 1,000, 36 words available for input-output buffering and job spooling support, and doubled the amount of memory normally available on the 7094 to users. By today's standard, this computer had an unbelievably stingy amount of memory, the equivalent of 393,000 skinny 6-bit bytes. Other input devices attached to the 704 was a disk about the size of a car. It provided only 55 megabytes of storage. I think your PC does better than that. And a terminal interface for the IBM Selectric typewriter, which didn't print much faster than a good typist. For NASA Glenn scientists and engineers, this provided a computer environment with a sophisticated batch processing and some limited user available storage. So while there was clearly lots of serious work going on in NASA, offered a really unique environment, and we had a lot of fun too. We had a speaker system that allowed the operator to make announcement to the users waiting outside the air-conditioned computer room. One night, my husband Al, who was quite a comic anyhow, and I ran a small batch of jobs waiting to be processed and disposed of the output. We then recorded a tape that started with, "Good morning, Linda, surprised to hear I can talk." We followed this with silly comments on each job. It took us about 4 hours to set up the joke, but we didn't charge our time. The next morning, everyone knew something was up, and Al's whole branch was up in the room to see the fun. When the operator, Linda, started the jobs, we started the tape recorder. The first words were, "Good morning, Linda, surprised I can talk." She came flying out of that computer room and said, "That computer is talking to me." As luck would have it, Al's boss, Dr. Albers, was showing some visitors the computer at that time. He asked Al to explain that it was only a tape recorder. Al's answer was, "Dr. Albers, you know its language has been getting a bit spicy lately." Dr. Albers tried to explain to the visitors it was only a tape recording. One visitor said, "I know, but how does that computer talk?" I'm sure she told people she heard a talking computer at NASA back in the 1960s. During all of this time, I had been an active member of the IBM Scientific Users Group called SHARE, a group that included representatives from NASA sites, universities like University of Michigan, University of Pittsburgh, et cetera, and companies like Bell Labs. I also served on the Fortran committee. Fortran is a programming language developed by IBM in the 50s. At this time, it was a relatively simple program. There were areas that I was interested in: handling errors in the Fortran runtime and developing more user-friendly input-output methods. As a member of SHARE and a NASA employee, I designed and wrote a set of routines called the Fortran error package. This package handles such errors as division by zero, floating point and fixed point errors that were detected by the hardware. If the errors were ignored, your outcomes would be garbage. The routine I developed would activate when these errors caused an interrupt. I also modified the Fortran library routines to activate the routine for illegal arguments, such as taking the square root of a negative number. My program provided the user with a backtrace to the main program, and the job would terminate on detection of the first error. The first day the error package was installed, we started with a backlog estimated to take about 48 hours on the 704. That backlog only took about 2 hours to complete. Since so many of the programs had errors, about 98%, users were not pleased. The users rebelled, and I was given 15 minutes notice to attend a meeting with my branch chief and a group of about 30 angry users. It was a full room. I explained to the group that these type of errors were giving them wrong answers and must be corrected. Apparently, I must have made a good argument because the branch chief said the software would stay, so I was happy. I did agree to allow the users to specify the number of errors they were allowed before the program was terminated. Of course, they soon realized they had to fix the errors regardless, and terminating the program at the first error was far more efficient. Our office volunteered to help in correcting the errors. It had been helpful that IBM was willing to modify the Fortran compiler so that I could develop the backtrace. They added markers to the coding so that my program could identify and locate problems. This meant that users knew not just there was an error, but in which line of code the error appeared. At the next IBM Share meeting, this was a group of IBM users, I described my Fortran error package to about 150 users and developers of Fortran and got a standing ovation when I finished. People were enthusiastic about the program, and IBM agreed to incorporate the subroutines into the standard Fortran library. In 1968 marked the beginning of an interactive access to support computer modeling, program development, and real-time test facility management with the installation of IBM's time-sharing system, TSS. TSS ran on the IBM 360 Model 67, one of the first machines built on a virtual memory architecture. This meant that the user was able to use a larger address space that was mapped to disk. This was known as virtual memory. Although the NASA Glenn worked with TSS for several years, it became apparent that IBM was not going to go down this road. Even though our users liked TSS, decided to discontinue it at that time. IBM did support a system called VM370, which used virtual memory, but it did not support the terminal access like TSS. Many viewed that decision as a misstep by IBM. Since NASA and others continued to use TSS and contemporary PCs use virtual memory concept. The next shift occurred when NASA purchased a Cray computer. I'm going to interrupt here for just one story. We also built a new building at that time, and we did not bother to put in a furnace. because we knew we were getting a Cray. Seymour Cray was an extremely interesting individual who believed orderly wiring slowed a computer down. The inside of a Cray computer looked like a bird's nest if you opened them up. And no two Cray computers were alike once they went into use in the field, since they were designed to be repaired by Cray support engineers. And getting that correction made just made the bird's nest worse. The Cray software is primarily a Fortran compiler and a very simple batch operating system. One of my jobs was to provide an interface to, and I needed something small to feed the Cray. I wrote this Sun program. I used a Sun computer because we had one available. I wrote the Sun program that fed jobs to the Cray and processed the output. The output could include binary card deck and output that was sent to a printer. The printers were very fast too. And I was a NACA NASA employee from 1954 until 1982, and when I retired from NASA, I worked as a system programmer for a NASA contractor, Robert Perry. Robert was someone who started at NASA as a computer operator. Al and I mentored him for many years, and over his career, he learned a lot and moved up to the ranks to officially become a systems programmer. I joined Robert in a new company he started. Our job was to provide technical support for time sharing, the Cray, and virtual memory systems. We also provided technical input for future hardware and software purchases. I became a member of the centralized mass storage team as a system analyst. The archiving software chosen for the evaluation was a system called Unitree. I worked with a young NASA employee, and we designed a wonderful interface to run Unitree on NASA computers. This system was not only to supply users with a reliable mass storage system where they could safely store information, but also to back up user workstations. Although we had a lot of disks, we actually backed the system up to tape, and 2 copies were sent to the NASA site Plumbrook, which sat on the shores of Lake Erie. Each week, we replaced the oldest copies. I don't think we ever had to use them, but they were there if we needed them. I worked at that role until I actually retired in the 1990s. I'm sure someone is going to ask me about salary or grade ceiling for women. I'm pretty sure there was one, but I have no proof. I did find something funny while preparing this talk. A friend of mine, C. David Miller, was on the board that approved raises. My name came up. I was at that point a GS-12. My name came up, and they were going to turn me down for a raise of GS-13 because I wasn't a manager. He spoke up and said I was the best system programmer in all of NASCA. However, GS level 13 above were reserved for management. The strange thing, I did get the raise. And the same day as was named head of the master planning office. And I think they did that so they could give me the raise. Since there were no other members of the master planning office, I expect this was the way to give me a raise. With that, I conclude I got one more page. We have now what is known as the cloud. There's no way to be sure, but I suspect much of the work we did through the share group was the beginning of the cloud. And that's my story of my years at NASA during an era of truly groundbreaking work in computing and technology. It was the first time computing was being integrated to such a degree for problem solving in the sciences. This represented a real paradigm shift away from previous methods of trial and error. With that, I'd like to conclude my talk, and I'd be happy to answer any questions.
So we have plenty of time for questions, and let me send out a thank you to Dave Blumenstock, who who told me all about
I was right.
So without Dave,
About the
we wouldn't
time.
be able to set this up. So thanks, Dave. Plenty of time for questions. Do we want to start?
I'm curious, were other women that started out in the same sort of role you did any of them follow the same sort of path as you, or were you fairly?
I was fairly unique.
Let's repeat the question.
What? Oh, I'm sorry. She asked if there were other women that followed the same path as I did. I'm sure down the road there were, but during that time I was sort of the exception.
Talk about Marge.
Oh, the interesting thing, my immediate supervisor was Marge Jareb. And I think I told the story about, did I tell the story about us testing the 704 and Sputnik? Well, and we became very good friends. And she finally got promoted to be a section head. And the way NASA worked, you had people, then you had section heads, and then you had branch chiefs. And I think she was overlooked for branch chief. And I know I was overlooked for section head. I was very, very angry when that happened. Yes?
Was there general support for the women who were in your group by the men?
She asked if there was general support for the men in our group.
For the women who were working?
Yeah, for the women. I don't know, I didn't notice. If they didn't like what I was saying, that's all right, I don't care. The engineers, particularly people like Aaron Boxenbaum that I named, there was another one, Dave Blumenstock, which at first, these were engineers I went out and worked for, and they were very supportive, mainly because I knew math and they didn't. Any other questions?
Sure, I had. Oh, go ahead.
What happened to that three-body math problem you did back in the 50s? Was anything ever done with that?
I don't think so, although, you know, I'm sorry, he asked what happened to the three-body math problem I did back in the 50s, did I say? I don't think so, although there were other people thinking about going to the moon. But until Sputnik went up, we really didn't get any support in that area. Aaron Boxenbaum, who I really loved working for, he was a nut. But he really did think outside the box all the time. Louis?
When the Sputnik was launched, what was the reaction in your office? Was it total panic?
Louis asked, when the Sputnik was launched, what was the reaction in our office? Was it total panic? I don't know, because I wasn't in my office. I was up in the computer room where they took my computer away, and I just got angry. But I think in the management area there was, and there certainly started to be a reorganization of NACH. And I think we got named NASA within a very short time, as I recall. Way back in the back.
Yes, what advice would you give to young women going into the sciences today?
What advice would I give to young women in science today? Don't give up. You're as good as the other side. I didn't have I had a pretty high self-esteem ego, and often used it if necessary. Anyone else?
Is there anything that you would have done differently looking back?
Is there anything I would have done differently looking back? Yeah, I probably should have been more aggressive in terms of advancement and so on. Did I tell you the story about how I got my GS-13? It's kind of interesting because in general, in the government, to be a GS-13, you must be a manager. And when I was preparing for this talk, I didn't remember this, but the day my GS-13 sheet was signed, there was also another sheet there where I was then called I forgot what they called me, but I got the advance to be a manager. Oh.
The master thing.
Yeah, it was, they set me up as being a master of the office on putting together a computer system that contained a lot of data. But I wasn't aware of it at that time, till I was looking, that they happened the same day, so I suspect. I had a very good friend by the name of C. David Miller that really went to bat for me, so that helped too.
At least they didn't make you a mistress.
No, he said this didn't make me a mistress. No, I had a husband. Yes, in the red?
So did you mentor other women while you were at NASA, younger women who were just starting out?
She said, did I mentor other younger women who started out? I certainly did. Well, I would mentor anyone that was needed mentoring, like Bob Perry happened to be a man, but I did mentor some young women too. Yes?
Could you tell us about the jump that you got when you got your 360?
About the what?
About the increase in productivity when you got your 360?
The IBM.
Actually, he said, tell me about the increase we got when we got the IBM 360. When we installed the IBM 360 at NASA Glenn, we installed the time-sharing system on that system, which IBM tried to kill. And there were a few of us, like the University of Michigan, Bell Labs, and so on, which didn't let it die. It eventually did. But the 360 was, I think I gave a speech at Share about, IBM not keeping up with what I thought they should on the 360. A lot of the software improvement of that system was done by people at Bell Labs, people like me, et cetera. And we finally had to give it up when the 370 came out. Now, they had a time sharing, but it was nothing as good as the original TSS. The original TSS sort of made it look more like you had your own computer, so I think the PC may be one of the end results of that. Yes?
You mentioned, Ray, that you started in math, and then you worked into computer, when computers came, started to exist. And you also said that your math background separated you from most of the people that just learned computers. Today, I guess one of the differences is a lot of people start out in a computer program in college, which didn't exist then. What would you say to, which would you say that math, or, let me back up. Today you might have a number of different programs, such as electrical engineering, or mechanical engineering, or math, or some physics. But what would you say would be the best direction to go along with computing?
Okay, he's asking what I think would be the best direction for young people to go today.
With the second major.
What?
With the second major.
With the second major. Certainly math has got to be either your major or minor, in my opinion. That was the one that served me the best. My chemistry didn't help me very much at all. Mainly because I think I didn't want to work in a chem lab after I singed my hair. But the math is very important, and one of the things I've found out is the engineering field doesn't really do a very good job in that area, in many instances. It depends on the school you go to. Some do and some don't. But I found many of the engineers at NACA in that time, that was their weakness, was in mathematics. Well, the fact that the headquarters couldn't understand that rotation of the, I mean, it was all done in math. That's why they didn't understand it. Aaron Boxenbaum was a real math type. And the other thing is, I think you need to be open to new ideas and be ready to explore. At my time, my time was an ideal time for being in the computing field. And I have to say, I was one of the leaders at that time. The fact that I wrote the error package for Fortran, and IBM actually agreed to put it in their product line, sort of exemplifies that. Be adventurous. Don't be afraid. Yes?
What kind of math did you study?
He asked, what kind of math did I study? I went up through calculus. Probably, I didn't get as far as I could have, as I probably would have in this day and age. Probably because my chemistry load was fairly heavy. And I was a disaster in the chem lab. I burned my bangs off more times than once. Yes?
Betty Jo, can you talk about your work with the mass storage system and how it could possibly relate to the cloud today?
Oh, yes, she asked if I could talk about my work with the mass storage system and how it might relate to the cloud today. Actually, I wasn't working, I was a contractor for NASA at that period of time. And we had this vision of putting together a program so that a user could simply send us their stuff and we would put it away and we'd keep track of it for them. And not only that, we not only kept track of it at NASA, but we copied everything to tape and sent it out to a safe place. In fact, it got put in a cave out at Plumberg. And I don't think we ever used it, but one of the things we had to do was come up with naming so that you didn't get conflicts. We had to, it was really a very interesting time. And a lot of that has since been solved in today's world. In my world, we didn't have such things as PCs. We had, as I said, the IBM 650, and I have to emphasize the amount of memory that computer had, and we thought it was great at that time. And when we got the IBM 704, which had the 32,000 words of memory, we really thought we had something great. Yes, Mike?
Were you involved at all at the beginning of the days of the internet?
Was I involved in the early days of the internet? I certainly was. NASA Ames decided they wanted to be able to send stuff out on a network. And so we installed the hardware that they came up with. And I think we had probably one of the first data transmissions across the country. This is my understanding, at least. And yes, we did get very involved in the internet and so on. I don't know if you all know about the SHARE organization, but that is an organization of IBM users. Plus, I think I got involved with another group that covered more than just IBM. But yes, I was involved in the internet. In fact, I think we had the first thing that talked across the country. What?
Betty, what year was that when you had the first thing that talked across the country? Do you
It's about the year of I think we had the 704 by then. It may have been, yeah, I'm pretty sure. Did I say when we got the 704? It was probably in the early 60s. And it was it wasn't that you dialed up and went through the telephone lines. We had a direct connection between NASA in California and NASA in Cleveland. We didn't do much with it, just wanted to prove it would work. Any other questions? Yes?
You still play around with computers?
Do I still play around with computers? I certainly do. In fact, well, I have a PC, of course, in my house and use it to play games and other things. But I still do a lot. I would say more of my communication is via the computer than it is by telephone. And as a matter of fact, that's another interesting story since you asked. I still remember when the first mini computers came out. My husband and I bought an IBM one. It cost us $3,000. It had, I forgot how much memory, it wasn't much. And the only thing we had was this really neat adventure game that we used to play. And the thing that was good about it is it made you learn to spell. Because at first it would sort of, if you gave it a command and misspelled it, it would sort of be helpful. But my son, who was having trouble in school, actually learned to spell on that machine because he wouldn't do anything if he didn't spell it right. But I think that's all it had. The adventure game, by the way, was written by MIT. And it was a pretty primitive computer. Back in red.
I was just wondering if you kept up with the direction NASA is going and how you feel about their current projects.
She asked if I still keep up with NASA, and I certainly do, because I had friends, some friends still working there. In fact, when I got ready for this talk, and I didn't use my pictures, which I had some of, I sent a message and asked them to send me pictures, and they sent me one that's me standing in front of the printer that was one of the first really high-speed printers that we got. But yes, I do keep up with Bob Perry, who I think I mentioned in the talk, just recently retired from NASA, and we are in communication all the time. He's the one that my husband and I sort of mentored. And my son, Sarat Salim, is a math professor at CU now, and I think a lot of what he got was because of Alan and I being in the computer world early on, is what got him started in that way. One interesting story about him, when it came time for him to go to college, we gave him a plane ticket to the West and said, go pick your college. And he picked DU. You had a question?
Yeah, when you were doing that mass storage, you had that picture, how were you communicating? Were people physically mailing tapes and stuff, or was it electronic communication?
He asked when we were doing the mass storage, was it people mailing stuff or was it? Yeah, was it? Well, in the first place, we had an interactive system in front of that mass storage system, and users locally could store stuff on it. We then took that stuff and copied the disks to tape, and that's what went out to the Plumbrook. And we used a system, you may have heard of it, called Unitree, which was written by a couple of guys out on the West Coast. I got very well acquainted with them because we used their software early on, and in fact helped develop some of it. And what it did was came up with a naming structure. And I think a lot of what is now on the internet came from that project. I suspect it did. Dave?
How much of your work during the 60s especially was related to the Apollo program?
How much of our work was related to the Apollo program? Well, I guess a fair, at least a lot of us had the dream at that time. Aaron Boxenbaum, who I mentioned, you know, back in the 60s to be writing programs to do trajectories to the moon was not usual. But he was an unusual sort of guy that I really enjoyed. But NASA Glenn was fairly active. In fact, the director of NASA Glenn, and I wish I'd have brought his picture with him, was a guy by the name of Abe Silverstein. And when NASA decided they were going to send astronauts off of the Earth, he was given the job of going and finding astronauts. One of the interesting things is most of the pilots he approached said, "No way am I going to get in this thing that I can't control and go shot to the moon." I mean, he really had to do some persuading to get the astronauts to agree to, because they had no control. And they didn't like that. Any other questions? Yes?
I remember when we went as Florida to see the shuttle off. I'm talking to you, you were telling about when you first went there, that the tower had its own rain cloud inside.
Oh, yeah, I did get to go to the Cape a few times. And in fact, I had a friend who worked out there. And you could have never got me to work where he did, because to get to his office, he was like maybe 40 feet off the ground, looked like 80 to me, and he had to walk on a 2x4 across to his office. Anyhow, this building, when it rained, when it got really moist, it would actually rain inside the building.
Talking about the vehicle assembly building?
Yes. Yes, and it was very tall. And I did get to see the inside of it.